Aloha, Richard Halverson here. This is ITS either 148 or 228. Today I'm going to go over assignment 5. That's the binary search trees assignment in spring 2022. So let me share my screen. All right, so the assignment 5 for both 148 and 228 are very similar. In fact, they're the same except for one minor little detail. And so basically, we go to the binary search tree chapter, and that's chapter 20 for ITS 148. It's chapter 5 or something for 228. But there is it's trees. And here we talk about binary search trees, and so you need to go through and click through all these previous sections so you understand exactly what a binary search tree is. Very simple concept. It's basically for every node to the left, every node down its left tree. Its left tree is less than the node, and every node down the right tree is greater than the node, and it's recursive. So with a binary search tree, you can traverse the tree in order, and you will output the key values in sorted order. So it's kind of handy that way. And so there's the algorithms are how to search for a key, how to insert a new node or a key value, how to remove one, and how to do in-order traversal, and how to do height, get the height and the number of nodes in the tree, and so on. For the assignment, we are supposed to, first of all, implement the binary search tree example in the last section of the chapter. It's 20.11, I think, for 148. I think it's 5.12 or something for 148. And so this goes through and explains how to implement the binary search tree algorithms that we should learn, that we learn in this chapter in Python. And so go through this, and at the very end, we have some code. And so basically, you're supposed to, for the first part of this assignment, you're supposed to just implement this. And so, we can click on this, and what this does is this takes these numbers here, 3, 10, 7, 2, 8, 4, 9, 5, 1, 6, and creates a binary search tree. And there's this nice little program here that will print out this tree print, will print out sort of what the binary search tree ends up looking like. And then you input a node to remove. So in this case, we're going to remove this one. And so then that would be removing this one. And after that one is removed, the binary search tree looks like this. And so, you can fiddle around with this. You can input a much larger binary search tree and see that it works. The code works great. And so the first thing we're going to do is implement it on our server. So I'm going to go to my server. I'll go to 148.com. And I'm going to go to cPanel. And go to File Manager. And go to Assignments. And the first thing I'm going to do is create an assignment 5. cat is bothering me. Well, I can't. So I'm supposed to create a directory named 5, and then I'm supposed to create these files in there and copy them from the example. So let's quickly do that. I want to create a folder named 5. And then in 5, I want to create file. Let's see, there was a node.py. There was a binary search tree.py. There was a tree print.py. And there was a main, is it main.py? Quite sure. Tree print main node binary search tree and tree print main.py. And then we got to fill these up. So let's go and get, let's get, well, here we are, tree print. Let me just grab this. Copy. Tree print. Paste. Save. Go to, I can close this because I don't need to look at that anymore. Now let's try node. Edit. Open. Go here. Go to node. It's just this. Copy. Paste. Save. And let me go to main. Edit. Go here. Go to main. And I'll go over this when we start running it. And then the last one, of course, is binary search tree. All right, so and in binary search tree, we're going to add these two methods. Okay, after we get it running, we'll just confirm that it works. And then we're supposed to, this algorithm here, I actually, let's see, let me hold on a second. Okay, I thought I think I forgot to save my file, but my Laulima when I updated this, but 5.2 and here it is combined. What okay, yeah, here it is combined. 5.2 is I think maybe I didn't refresh this or something. There is no 5.3 anymore, and I just combined adding the BST in order method along with the height figure out the BST height, the get height method. And so here's the print in order method, and here's the get height method. And we're supposed to write those as Python methods, because this is written in some bogus algorithmic language. You know, there's no forward arrow, but you know, there are languages that are like this, of course, much closer than Python is. And then we can modify the main program so we actually print out the height of the tree and the in order traversal of the tree. And so so first of all, let's confirm that what we got over here runs. And so let's go to main, and let's open up a terminal. And I'm going to go to assignments. 5 LSL, oops, LS space dash L, and there's my main. So I'm going to do Python 3, because that's Python 3, main py, and okay, insert some values. Let's see, do I got some nice, well, I guess I'll just insert what there was there. It's this, copy, paste, and this displays out the initial tree. And then we can remove something. And so if we remove like this 4, let's remove 10, see what that looks like. Remove 10. And so now it looks like this. So now 10 is gone, and the tree, the binary search tree rearranges itself, because that's probably the hardest algorithm in the binary search tree in the set of methods that go along with it. So anyway, it looks like this works. And what we're going to do now is, let's do part 2 here. And that is adding this method and this method. Okay, so now it wasn't until I started doing this assignment when I realized I should have worded it differently, because I probably shouldn't have made it an actual method of the class, but just it didn't need to be part of the class. It could be, you know, external to the class, but it doesn't matter. I worded it this way. And so let's, so the first thing I'm going to do is I'm going to go to this binary search tree class, and I'm going to add, let's see, def space. I'm just going to grab this like this, grab it, copy, and go back over to here, and I'm just going to do a paste. And I'm going to fix this. And so let's fix it first. Let's see, it's a Python, so it looks like that. We got to throw a self in here. And we don't use curly braces, we put colon. And we need to indent if we don't indent just to make it look pretty. We indent because that indicates it's a block. In Python, oh, this is going to be a colon. And I think it's like if node is none. If node is none, then return, just return, I guess. Otherwise, okay, we are printing. It's almost not even necessary that we understand what the algorithm is. We'll see how the algorithm works after we get it running. But here we're still just doing the mechanical process of converting the algorithm as it is described into Python code. So here I want to, so what I do is I print, let's see, I'm going to find some notes I have around here. Okay, so let's go back and look at node. What a node looks like. For a node, it's got a key value. It's got a left, which is going to be another node or nothing, and it's got a right, which is going to be another node or nothing. And so and what this is print. This is a recursive method, and when it's called, we have a node that we want to print, a node being a tree that we want to print, and so the first we're going to check to see if there's really a node there because we're passing it down. If there's not a node there, then we don't want to do anything. We just want to return. Otherwise, in order means print your left side. First print your left side, then print U, then print your right side. So and if this is called recursively, then the first print your left side is going to be calling down to the very leftmost node in the tree, and then it comes up and prints the parent, and then it prints the right node, and you'll see how this works. Anyway, so here we want to call ourselves, and because it's inside a method, we have to do self dot, and we want to call node dot left, and just like it's described here, node dot left and node dot right. So first we print what's on the left, then we print ourselves. And to print ourselves, I'm just going to print the key value, and I want to print it all on the line. I don't want to print the carriage return, you know, like in the regular old print statement in Python. Always prints a carriage return at the end. I don't want that, so I'm going to just print node dot key, the key value, followed by end equals a space, and so that way it will print the carriage return. So that prints myself, and then I want to print my the right of me, and so this is self dot to the right, node dot right, and I think that's it. That's simple. Okay, so now I've got this print in order to work. So let's go back here to main, and I'm going to modify this to print the in order. So I'm going to do print let's see. Something like in order traversal comma and equals space. Right, okay. And then I want to try to do it. So it'd be tree. So it's part of the object. It's a method in a tree in the tree, because the tree is a binary search tree object. So it's a tree dot bst print in order. That's the name of it. Let's see, print in order. So I want to print that, and starting with the tree root, the root. And then it doesn't print a carriage return at the end, so I got to do a print. I got to do that to print the carriage return at the end. And let's do the same thing after I'm done removing after I'm after I'm done removing the value that I want to remove, I think I'll put another print in here just to make it. Another carriage return in there. All right, let me try this now. Okay, so I have incorporated my BST print in order method into the class, and I'm going to try it. So go to the terminal, and so insert some values. I'm going to insert some different values. Got some nice values here. There's some good values. And it printed a tree. And it says, in order traversal, trace back, blah, blah, blah. Something didn't work. Doesn't? It's because I forgot to save. Yes, I forgot to save. Let's try this again. And maybe still do that. Yes. Okay. In order tree traversal. So this is the in order. So first you go left, first you go left, first you go left, first you go left. Oh, nothing there. So return, print, go right, nothing there. Then you're done. So you return, print, then you go right, nothing's there. So you return, print, and so that's what happens. The 199, the 300, the 323, the 359. So you see it's in sorted order. So it's kind of a neat way to sort. You have all these things and you dump them into a binary tree, and then you do an in order traversal, and you see what you dumped in is in order. So the in order works. Oh, let's do a value to remove. Let's remove I don't know, let's remove so if we remove 323, then 359's got to go up and take its place. If we remove 470, then 461 has got to go up and take its place. So I'm going to remove 470. I want to see what that looks like. Yeah, okay. Now it's different. Oh, 649 went up and took its place. 461 stayed down there. I wonder how it decided that. Anyway, so now 470 was right there between 461 and 649, and now it's not there, because it was taken out. Okay, so in order traversal works. So what about the other one, which is figure out the height. Oh yeah, here I tell you how to modify the main program. Okay, so all right, so let's do this one. Copy. It's over here, and it's going to go in. I'll just put it right here. Def paste, and I'm just going to get rid of these curlies. Colon. I'm just going to drag them all back and re-indent. Okay, so this goes in there, and this goes in one more, and there. This is a period. This is a period. This is node is none, capital N, and I don't need the parentheses. And I got to put a self here. So the way this works is it's recursive again, and so the height of the tree is it looks at the height of its left subtree, and then it looks at the height of its right subtree, and it takes the biggest one, and max is a Python method, so that's fine, and so it takes the maximum, and then it just and then so it knows that its height is the maximum of either the left or the right, plus one, because you add yourself onto it. So then that's what's returned. You figure out the maximum of your left child and the maximum of your right child, subtrees, and then you add one to it, and then that's the value that you return as your height. And so this thing returns up, and at the end you have it has added up all of the levels, and it gives you the height of the tree itself. So I think this might be all I need to do. All right, and a tree that is just itself is going to be the height of 1. So a tree of just itself is going to be the height of 0, I guess. Because if it's none, you return a -1. All right, I'm not sure. You can check on that when you read the chapter. All right, so let's see how this works. And now we can go back and just go ahead and add this code here. And actually, all we're doing is we're adding. Oh, I put the height above right after the printing of the tree, didn't I? So let's just might as well put it in the same place. So I did something like this. All right, let's see what this looks like. Put these in there. I'm going to copy this, do the same one. All right, so let's, there was a traceback. Oh. All right, so let me paste this. Something in there. All right, so okay, so it's because is it because I forgot to save it again? Yeah, wow. Let's try it again. I forgot to put self in front of some things, I bet. I should put self. Yeah, let's see if that helps. There we go. It's a height of 4. Yeah, 0, 1, 2, 3, 4. So it's 1, 2, 3, 4. I see. So you count the legs, you count the edges, not the nodes. So 470 by itself has 0 legs, and then 323 has got, okay, so what happens if I remove 461? If I remove 461, it should go, the height should go down to 3. So I'm going to remove 461. Oops, 1. And look at that, it's 3. All right, well, anyway, so now what happens if I try to do the SU 22 dot, oh no, SP, this one. And I put me in there. And I try to see if this, what this looks like. Just hit refresh, it's buggy. Now, the difference between this assignment and ITS148 is for 228, you have to be able to, this call, you have to be able to take, remove this. If you don't specify a node to get the height of, if you don't specify the node, then it assumes that it's the root. Okay, so for, and same with print order, it assumes the root. So in 228, just really quickly, let me show you this. In 228, see, you don't put, you have to be able to do it where you don't put the root node. It just assumes it's the root node because it's not specified. Okay, so that means that these have to be different. You have to do something. This has to be a little bit fancier. These two things have to be a little fancier. And so when this thing finishes, and don't hit refresh or anything, because then it's just going to start 2 of them. And I'm not, oh, here we go. All right, so so this is your program, displays out this stuff, displays out some stuff, and you got all the points. Great. So let's do the next one. I'll spare you. Okay, so it inputs an original set of numbers and figures out the binary search tree, and it turns out the height is 6. And this is what it, traversal comes out, looks like that. And then it removes 3 nodes and brings it down. The height comes down to 4. And you can, confirm this. You can mess around with the main thing. I turned this into a loop where it would keep on adding. It would keep on asking me values to remove until I entered a 0. And that way you can fiddle around with it more here. Go like this. While remove value is greater than 0, then do all this stuff. And then at the end, you want to do this again. So then this thing will now loop. It can loop. So if we run it now, and we can see if, let's paste. Oops. Nope. Let's run this again. Stop that. And let me grab this. This is the original. And let me paste it here. And so, and then we can remove 948. And that looks like that. Then what? Oh, I don't know what we could remove now. 373, 528, 673, 897, and now it's height to 4, went down from 5 to 4, until finally we go 0, and then it ends. Anyway, now so what you have, if you're in 228, then I've explained that you're going to have to modify these two methods. So when you don't include, so in other words, you got to do a default. If you don't, if it's not a node, or it's not none, then it must be the root. So anyway, okay, I hope that helps, and see you next time. Thanks for watching.